Hello everybody. Today we are going to see a very interesting topic. This is about active noise cancellation. So you must be wondering like what exactly is active noise cancellation. So many of you would have heard about this technology and this is being applied almost in every industry vertical. But even today people are confused. What exactly is the reason this particular technology is being adopted? So many industrial verticals, no matter it is FMCG or consumer goods, electronics, heavy engineering, aerospace, automotive, every industry that you name uh, is now barging into this particular field called active noise cancellation. So let's try to understand what it is and why it is important. Active noise cancellation, which is presented as ANC, is a technology that drastically reduces unwanted external noise. So in our day-to-day life, we would have heard many noises. So why we call it as noise is these kind of sounds which is emitted by any system, okay, which is unpleasant to hear, is generally referred to as noise. So these unwanted external noises are to be cancelled. Okay, and once the unwanted noises are cancelled, pleasant noise comes into picture. Say, for example, in a movie, if the echo is reduced, the sound is audible, it's pleasant, the music is very pleasant. So now this can create a very quieter and more immersive listening and communication experience. So what we mean by quieter and more immersive listening or communication experience. So quieter is like it's absolutely pin drop silent. So you only listen to those sounds that you want to hear. Otherwise, all the other noises or the external disturbances are cut off. It is reduced. And why we call it as an immersive experience is, say, if it is a song or a music, people tend to immerse into it. They try to get into the core of it and try to understand the words, the meanings, and the situations. And that's how an immersive experience comes into picture. So similarly, any sound which is pleasant to be heard, okay, we try to get into an immersive listening or an experience. So active generation or active noise is a sound wave that is precisely designed to cancel out the incoming ambient noise. So, which means there is a noise which is generated, and that particular noise from the source when it comes to the sink. So, that is from the speaker when it comes to the listener, it mixes with all the other external noises, okay, which is a disturbance, and the listener will not be able to get that particular ambience. The listener will not be able to get that particular feel. So that's the reason we call it as uh, ambient noises. And how it works is an active noise cancellation system employs a microphone to detect and analyze the incoming external sound waves. Okay. Then a specialized chip or a processor creates an inverse sound wave. So which means that there is a sound which is coming and that comes with a lot of disturbances. So a anti-noise or an inverse noise is generated through a microphone, which will be inverse. Okay, which will be with a phase difference. Okay, so if there is a noise which is generated uh, in one sinusoidal form, then the anti-noise will be generated exactly the mirror image of that, the inverse of it, so that it becomes an anti-noise. And our intention is to cancel the noise with the anti-noise. So that is how the noise external disturbances are reduced, and this is done using a chip or a processor. Now, these two waves, the original wave and the generated wave, they meet they meet effectively at one particular location and they cancel each other. So, complex in understanding because, like people often say, like, yes, I am able to hear a noise or I am able to hear a sound. And I hear that particular sound with all the external disturbances. So, which means that it's a bit complex for me to visualize how all the other disturbances, because it could be a disturbance a speaker which is like aired out at least from a distance of some 500 meters, and there could be traffic on the opposite side and there will be disturbances or noise generated from that particular traffic. There could be a machine which is operated in industry and there could be noise from the industry. So there are different kinds of noises, okay, which is going to mix or combine with the actual music. Okay, so now how do we filter out all these noises? Because it's very difficult because each noise or each sound will come with a different amplitude. So let us say there is an amplitude A1, there is an amplitude A10, different sources from where different disturbances come into picture, and all these disturbances are going to mix or combine with the actual music that's being aired out, or maybe within the like the what do you call the studio. Let us say it's a studio. So now what we do is there are two different ways of cancelling the noise. So initially what we do is within the studio there is a lot of packing done on the walls so that all these disturbances which is caused from the outside environment does not diffuse internally. So that is the most important and the most frequently used. So that is what we call as passive noise cancellation. So there are situations when most of the noises get cancelled or completely distracted with the passive noise cancellation systems. So some examples are fabrics, or some foams or fabrics or thermocols. These are all some building materials which has got a good acoustic property, reflective property, or it has got an absorption property. So we make use of building materials that has got a good absorption capabilities. So using most of these absorbing materials, building materials, most of the sound is absorbed. Okay, whatever comes from outside is getting absorbed, and whatever echo is generated within the studio, that is also observed. So now there will be very feeble noises which are generally low frequency. So low frequency noises are nothing but those noises which is ranging from 2 hertz to maybe about 1 kilohertz, or not 1 kilohertz. You can say about say 1000. So yeah, 1 kilohertz you can say about some 600 to 1 kilohertz, 600 hertz to 1 kilohertz. So now anything within the range of 2 hertz to say about 100 hertz or 600 hertz, okay, that generally is treated to be low frequency. And these low frequency noises are very difficult to get cancelled. Okay, so now there is no building material that will be able to absorb these noises because these are very weak, and these weak noises need to be cancelled using a different phenomenon. That is what we are using here. We are making use of microphones. We are making use of a specialized chip and a processor, which we generally call it as a controller. And making use of this controller, that complete noise is getting distracted. Okay. Now there are three different types of active noise cancellation process. One is a feed-forward active noise cancellation, where microphones are placed on the exterior of the headphone or earbud. Okay. So now let's assume that there is a headset. Okay, and on that headset, okay, we have a system with which we are able to hear the noise. Now here what happens is the microphones are placed exteriorly so that these microphones will try to cancel that particular noise which comes onto the listener's ear. Okay. So even before it reaches the listener's ear, that gets cancelled. That is called feed forward ANC. Now feedback ANC, there is a microphone which is placed inside the ear cup, close to the listener's ear. Okay. So this is getting monitored and that particular noise which is already passed inside and within the ear, within that earbud, within the ear, that noise gets cancelled. So these are the two main types of ANCs what we see. So one is cancelling it outside the ear, one is cancelling inside the ear. So inside the ear we have every possible things. From very long back we have such system like our headphones, earbuds, earplugs. So when we go to a industry, when people working in the machineries, with the machineries there, they have earplugs, and these earplugs are capable of cancelling the noise, okay, the external noise within the ear. Okay, so now what happens is even that particular earplug, okay, we cannot say that it's a 100% efficient model or system. When people, on a long run, these people they get into all kinds of psychological issues. So that's the reason, like every fortnight, they are taken for a counseling to understand whether they are going through any kind of psychological problems because of continuous noises. Okay. Now there is one more thing which is called as hybrid ANC, active noise cancellation. So this combines both feedback and forward. Okay, so these two, and this is very comprehensive. Okay, so now let us, try to see like where are all these applications found and how they are using it. So let's say the headphones and earbuds. So headphones and earbuds, everybody have seen that these are the most common applications allowing users to enjoy music, podcast or calls without the interference of background noise like traffic or airplane engines, etc. So this is the usual and the most seen and most known kind of active noise cancellation technology, earbuds or headphones. Then we have the active noise cancellation technology for the aviation and the automotive system. So here there are different technologies, and today let me just explain you about our technology. And this quiet bubble technology is nothing but this is a process where there is a virtual bubble which is around the head of the driver or the passenger. Okay, and that is of some calculated specific range. And on the external helicopter or the passenger car, it gets diffused into that particular virtual sphere bubble. Okay, entire noise gets cancelled, and within that particular bubble, the passenger or the driver is very comfortable. He or she will not be able to hear any other noise disturbances. See, there are two different things. One is cancelling the noise within the ear, cancelling the noise outside the ear. So now in the case of aviation and automotive systems, we are trying to cancel it outside the ear because the intensity of noise that is going to come from outside is going to be extremely large, relatively large. Okay, so now there are going to be huge noises, mid-frequency noises and high-frequency noises. Okay, and apart from the mid-frequency and high-frequency noises, there is a very low amplitude and weak pulses or noises, which is generally low frequency. And now these low frequency noises are very difficult to cancel. And using this particular technology, where in the case of aircraft or in the case of passenger cars, the headrest is opened. Okay, and within the headrest there is going to be two microphones and speakers. Okay, and then on the roof of the vehicle, okay, there are going to be several microphones to be installed. So these, in the case of stress simulation, we say that there are hotspots, those regions where there are concentration, high concentration of stresses, we call it as hotspots. So similarly, there are hotspots for acoustics. These locations are identified, mapped, and then there is a combination of microphones set. Now these microphones will be capable of generating an anti-noise. Okay, and this anti-noise, whatever is generated, okay, to the external noises, different kinds of noise. In case of aircraft, we have a noise which comes from the jet engines. So on the right of the wing and on the left of the wing, there are going to be one or two jet engines. So it would be either two or either four. So depending upon the type of the aircraft, whether it's a narrow body aircraft or whether it's a wide body aircraft or whether it's a commercial logistics carrier, okay, those kind of aircraft. So depending on that, the engine capacity also increases. So now as the engine capacity increases, there are going to be a lot of acoustic pressures developed on the aircraft. So aircraft is nothing but it's a thin shell, and it's like something like a pressure vessel. So these noises are going to be diffused inside the aircraft. Now, apart from that, there are going to be turbulent noises also across the aircraft. Aircraft is at a certain velocity. Okay, there is going to be a huge amount of air pressure, and covering up the aircraft. Now, at a fewer times, at some specific time, there are possibilities for turbulence, and these turbulence are also going to, act like a blanket which is going to cover the entire aircraft. And some situations, these turbulence can create jerk, inertial jerk, and there is a possibility for the aircraft to shrink or buckle or cripple. So there are different kinds of pressures which acts on the aircraft. So acoustic pressure is also one such dominant pressure that acts on the aircraft. Now these acoustic pulses, pressures, have to be reduced within the cabin. So cabin is primarily, made using aircraft grade aluminum, and then it has got a covering material, fabrics, different kinds of fabrics are put, thermal insulations, and then these fabrics will also help in climatic control systems. And then there are in both plastic, that is composite based structures, which is kept inside. So like how the automotive interior we have, the dashboard and all the other, the A pillar, the B pillars, and all those things covered with plastic parts. So similarly, composites are used as the fabrics inside. Now, making use of these many systems, passive systems, huge noise is generally cancelled. Now, still there are going to be very low frequency noises within the cabin. And now these low frequency noises will be cancelled using this particular technology. Okay, so here we have a combination of speakers and microphones. These speakers and microphones are kept as an array at some specific locations called acoustic pressure points. And now these microphones will be generating a specific amplitude of waves, okay, which is generally the anti-noise. Now, in the case of automotive, that is the cars, the passenger cars and trucks, we have many noises. So one is the engine noise, which comes from the bonnet region. And then we have the powertrain noise, which comes from beneath the structure, the automotive structure. Then we have tire noise, which will take the undulations, the abnormal undulations from the ground, that is the road surface. And now these harmonics responses are again converted into acoustic pulses. And apart from that, there is going to be passerby. There will be different kinds of vehicles which is going to pass from either sides. Okay, so that will also exert a pressure on the vehicle that is again diffused inside the cabin. Then there will be a windshield noise, and windshield noise is also a big contributor. And likewise, all the different kinds of noises is generally diffused inside the cabin. So once this system, enters the cabin, there is going to be a huge amount of disturbance. This is specifically cancelled using the active noise cancellation technology. So this particular mechanism of placing the speakers, okay, will be mounted on all the headrests, the passenger as well as the driver headrests. And now every person, that is the passenger as well as the driver, will have their own privacy. So within that quiet bubble, whatever I told you, within that zone, they will be completely private. They won't be able to hear what the other person talks. They won't be able to even hear the disturbances which comes from outside the car, outside the vehicle. And then there is a possibility for them, not the possibility, there is a capability. Okay, using this acoustic, the active noise cancellation technology, there is a capability of even having private zones. Say, for example, there is a CD which is played in this particular music. Okay, there are about n number of, say, about 10 number of musics or songs which is played in the disc. So the disc contains about 10 or 15 songs, and each passenger has, has the liberty to hear his or her, based song. So this is also made possible. So, which means a complete personal immersive experience, user experience can be, achieved through the active noise cancellation technology. That is the hybrid active noise cancellation technology. Now, let us also discuss about system where the active noise cancellation technology can be applied. So, this is within the kitchen. We have the cooking range. Okay, we call it as chimney. So this is basically a low frequency noise. So where the moment the ladies they cook in the home, or the gents, the hotel people who cook within the kitchen, there is a lot of oil spills and smoke and fumes going on. Now all these things have to be conveniently removed from the kitchen, and making it usable or workable. Okay. Otherwise, what happens is, because of huge temperature, usual temperature, there will be a change in temperature. There will be enormous heat also generated, which will create a hindrance, for the cooking range or chimney, which is used to remove all the unwanted smokes or fumes from the kitchen. So when this operates, there is going to be a humming noise which comes. This humming noise is a very low frequency noise, and this humming noise has to be eliminated. So this particular kitchen system has got, nowadays it has got this active noise cancellation technology which is embedded into that. So what happens is, the noise is getting generated at the source itself. So where particular vibration comes, the structural vibration, comes on the chimney, that particular location itself, the noise is getting captured. So this is exactly, the same quiet bubble technology which I told you in case of aviation, that is the aircraft and cars, the passenger cars, automotive technology. So similarly, the same technology is used here in cooking ranges of the kitchen chimneys. Okay, and this can also be effectively used in the case of FMCG industries, like washing machines. So when the washing machine is under operation, there is going to be a good amount of noise which is going to get generated when the the hub, the drum of the washing machine, that keeps rotating, and when this keeps rotating, there is going to be a huge structural vibration which is generated inside. This structural vibration diffusing out of it will create a noise. This is going to be again a disturbance. Okay, so now this particular low frequency noises can be uh, reduced. Okay, in the case of washing machines and many of the kitchen systems. Okay, so there can be a question whether this can be 100% cancelled, whether the active noise cancellation can be 100% reduced. Say, today's technology, the active noise cancellation can be reduced from 20 decibels to a range of 40 to 45 decibels. So I happen to be working with a Israeli company, a high-tech company called Silentium Limited, and this particular company is a pioneer in active noise cancellation. So we have collaborated, and worked with many of the automotive OEMs, and we have also worked with PG companies. We have worked with Whirlpool, Bosch, Siemens, so many companies. Even these low frequency noises, the active noise cancellation technology can be used in the medical health near industries also. Your MRI machines or the CT machines. Okay, that also generates. Okay, the alternative that electromagnetic fields when it gets generated, if the patient is put or pushed inside that particular chamber. Okay, there is a huge rotation. So that is like the magnet, the electromagnets keep rotating. So that also generates a low frequency noise. And these low frequency noise can be uh, completely distracted or reduced. So instead of saying that 100% noise cancellation, we can say about 20 to 40 decibel, or maximum with today's technology we can reduce it up to 50 decibels. So let us imagine a product is designed in such a way that the specification or the regulations says it should not go beyond 25 decibels, or say 90 decibels. That is the allowable. So using the active noise cancellation technology, we can reduce it further by 20 decibels, or say about 40 to 45 decibels. So which means anything that is about 90 decibels can be reduced to 50 or 55 decibels, which is very much within the safer limits of regulator. Okay, so this is all about active noise cancellation technology. So maybe I can create a specific video that shows the installation process and how this active noise cancellation can be experienced. See, there are two ways. Either we should be in a position of hearing it and judging whether that noise has reduced, or we should be in a position of understanding spectral images where looking at the color contours, the mapping system, color contours will be able to represent the zones where the noise is reduced and the zones where the noise were high. Okay, so there are color mappings, and based on these color mappings, we will be able to find out. This is these are the two three different ways how we try to understand this. And now there is one instance which I would like to share, where myself and one of the technical managers from Israel, from this company, we had gone to Bosch. So Bosch has got an industry, a specific industry that is completely manufacturing all vehicle electronic systems. And now that particular industry has got almost about 50 machineries in one particular unit, and then about some 150 200 machineries in the other unit. Now these two units, the machineries were of different orders. In a sense, like unit A, all these machineries were all operating in the zone of 100, decibels. And unit 2, most of them were working about 85 to 100 decibels. So now their requirement was to check if this particular noise could be controlled using active noise cancellation. So as I told you, passive systems can reduce noise or cancel noise to some extent. Still, it won't cancel noise. It will be able to absorb the noise. It can diminish it or completely destroy that. It can capture those noise. Okay, that is possible using passive systems. But active noise cancellation, what it is going to do is it is going to destroy that particular noise. So we had taken it as an engineering services, and the engineer had mapped the noises, the acoustic hotspots, the entire industry, that is unit A, and then found out those probable locations where these microphones are supposed to be installed, and then the speakers. So now microphones, the speakers, is kept in an array, and based on that, the anti-noises were generated, and all those noises from the source, anti-noises from the microphones, they had to cancel, and we canceled it exactly at the location where the operator is located. So which means from machine about 1.5 meters on either side, on all the three sides. Okay, and there is a virtual bubble which we had created. So which means it's a virtual bubble. You cannot see that. We have to assume there is a bubble, and within that particular bubble, particular machine operator was very, very convenient. So earlier, Bosch was using an earplug, because most of the industries across the world, they were using earplugs. So now slowly, the systems are changing. So most of the active noise cancellation technology has created a good facilitation in most of the industries, saving the operator from the psychological damages, because over a long run, the repeatedly the operator is subjected to noise. Okay, so now using this technology, the operators seem to be convenient working for long hours. Okay, so today, this particular session or the episode completes here, and I'll be really happy if you are able to raise in comments or queries and all these things to happen. Primarily, I would like you to subscribe and share this particular episode and let it have a maximum reach so that people can come out with their own ideologies or doubts, and these queries can be discussed. We can probably have a WhatsApp group also on a long run where like-minded people can come and we can always host a discussion. And we can also share our experiences on this particular platform. So kindly subscribe and share this particular episode. Okay. So thank you very much for your patience and your efforts in trying to understand what is. Okay.